Hey, so in this video, we're going to discuss today's Leetcode daily problem challenge, which has a title of Bitwise XOR of all pairings. So the question goes like, you're given two arrays, nums1 and nums2, where you need to find out its XOR and all the pairs XOR, and you need to like XOR them together themselves, and you need to have a final output. Let's just give an example to have a better idea of this. So the example goes like nums1 is 2, 1 and 3. Nums2 array is 10, 2, 5, 0. So the way to do it is, so you take a XOR of 2 with 10, you take an XOR of 2 with 2, you take an XOR of 2 with 5, you take an XOR of 2 with 0. Then you get these numbers over here, 8, 0, 7, 2 respectively. Then you simultaneously do XOR of 1 with 10, 1 with 2, 1 with 5, 1 of 0, and then you get the next four numbers. Then you get the XOR of 3 with 10, 3 with 2, 3 with 5, 3 with 0, and you get the next four numbers. So after receiving this array, you XOR each of them with the previous result. What I mean by that is, you XOR 8 with 0, you get the result. You get that result, you XOR with 7. Then you get that result, you XOR with 2. Then you go on, go on, go on, go on, up till you have all the numbers XORed with each other, and you have one single output, and you need to return that output. That's the problem. I hope the problem was pretty clear to you. So we're going to discuss three approaches here. The first approach is gonna be a brute force approach, where you just try to find out whatever possible combination are there, and you just XOR them together. So the brute force approach goes like, you have an array such as, so you have an array, let's say 1, 2, 3 for nums1, and you have nums2 as 4, 5, 6. Now what you do is you maintain a dynamic array. Dynamic array could be a vector in C++, it could be an array list in Java, depends upon the language you're trying to put it in, but a dynamic array. So you just iterate over both these two arrays, and you just find out the result that you were getting previously. So you XOR this with this, then you note down the output in a dynamic array. Then you XOR this with this, you note down the output in a dynamic array. You XOR this with this, you note down the output in a dynamic array. Simultaneously, you do for the other two as well. Then you get 9 entries in the dynamic array. Once you get those 9 entries, you XOR them together after iterating the array, and you get the final output. But the concern here is the limits of the problem won't allow you to do that, to have such dynamic array of 10 to the power 5, to store 10 to the power 5 numbers in it, and you're gonna get a memory limit exceeded, which I did as well. So just for intuition purposes, I'm going step by step on how you can go on and optimize the solution and get your answer accepted. So I tried that as well. I got a memory limit exceeded, but we can look at the code on how the code could look like on what we just discussed. So you got a dynamic array, and you are iterating on all the possible combination via a two for loop, one nested for loop, and then you're just pushing back, inserting the element into the dynamic array after getting the XOR of each possible combination. Now that you got the dynamic array filled up, then you iterate the dynamic array, then you XOR each of those elements with the previous results of total XOR. Total XOR is just the output, and then you return the total XOR after you got that. In this case, you'll get memory limit exceeded, because it seems like because of the constraints, you're not allowed to have this much space being used by the algorithm that you use. Okay, so we got that. Let's just do one bit more small optimization here, because we got a memory limit exceeded here. By the way, the space complexity of this algorithm would be O of n, and the time complexity would be O of n square. But in this case, you are getting memory limit exceeded. So what you do is you go with another of the approaches, which is You just remove the dynamic array altogether and you calculate all those XORs runtime. What I mean by that is, let's just go over to the code to see on how it actually works. Okay, there's the code. So what you do is, as you would remember, we were using two for loops to calculate the possible combination, right? Um, this here, this here, this here. Two for loops, and your main logic goes here. And you had an dynamic array. So scrap that dynamic array. You have a number, a variable, to calculate what the total result have been so far of these operations. So, for example, you have 1, 2, 3, 4 as nums1 and nums2. So 1 into 3, you store it in a variable beforehand, and then you get this beforehand stored variable and you XOR with the new combination of 1 into 4. So you got the output from here. Now you store that output and you XOR with 1 into 4 to get the new output. Similarly, to get the further more output, you have the output of these operations. You take that output and you XOR with 2 in 2 XOR 3 to get the new output. Once you have the new output, you XOR with 2 XOR 4 to get the new output. So you go on like this to get the final output. So the code would look something like, as I already mentioned, you have a outer variable, so, and you are just XORing the previous output that you got and with the new XOR product, basically the possible combination of elements that can occur, uh, which also gives also not gives us the full blown optimized solution and gives us a TLE. So the we have optimized space here. We are not using a dynamic array anymore. So the space complexity will get reduced down to O of n, but time complexity is still O of n square. So how do we get that optimization of time here? So as you would have seen, let me just show you here. Using this algorithm, you get a time limit exceeded after doing a one step forward of optimization. Now, you do an optimization on the time. So we know that we cannot iterate the array twice, because that will cause the time complexity to be O of n square. So there should be a way for us to only iterate the array once and get our output. So how would that look like? Before that, I need you to focus on a few properties of XOR. Let's just look into it quickly. So XOR is basically an operation. So you have 1 0, 0 1, 1 1, 0 0. So whenever you have like same inputs, sorry, my bad. You have same inputs, you get 0. And when you have like different inputs, you get 1. That's XOR for you. Now there's a property here, if you would have observed here. Let's just that XOR with the same input gives you 0. Basically, that's a identity for XOR. So whatever we are doing a lot of redundant jobs here. So let me just show you via an example. Let's say the nums1 array is A, B, C, and the nums2 array is D, E. So I'm going to represent the XOR of A, B as AD, just noteworthy. So you XOR A with D, so you got AD. You XOR A with E, you get AE. You XOR B with D, you get BD. You XOR B with E, you get BE. You XOR C with D, you get CD. You XOR C with E, you get CE. Observe that same elements are getting used multiple times. For instance, so you need to like XOR them with each other as well. This will get XORed with this will get XORed with this, and this will get XORed with this, and so on to get the final output. But that's not the point here. The point here being, you will have A being repeated twice, which just cancels out the existence of A altogether. Similarly, you have B repeating, so this will not have any effect on the final output. You have C repeating, which is, as we already discussed, is identity. You have D repeating, you have E repeating. The only contributing factor to the final XOR is D and E of the second array. So we have started noticing a pattern here. There must be a pattern here that we could use that would allow us to get the final output in one single iteration. And you would have guessed it right. To know how many duplicates are there, how many duplicate operations we were doing in the previous unoptimized algorithm of O and N square, we need to know how many duplicates are possible. And for that, if you would already observed, there's a pattern here. The pattern goes like, if the inputs numbers array is even in size and the other is also even in size, there's a pattern that you can get. Similarly for even odd, one is even, one is odd, and both are odd. Let's just discuss them one by one. Okay, first we'll discuss even. So let's see the try to get the pattern. A, B, C, D, both are even. We got that. So now you get with this A, C, A, D, B, C, B, D. So C will get ruled out, D will get ruled out, A will get ruled out, B will get ruled out. So doesn't matter whatever the input, if both the arrays have even number of elements, then it corresponds to identity, that is zero output. So you can just return zero output if you have both elements as even. Let's just now discuss the second prop, or you could say pattern, that if one of them has even elements and one of them has odd elements. So let's just take an example for this as well. Let's just say there's A, B, C, and D and E. Now you get A, D, A, E, B, D, B, E, and C, D, C, E. Now A will get identity, and D will get identity, E will get identity. So you're only left with B, A, B, C, D. Okay, wait a minute. So let's just like try to do a similar thing together once again. I think there was a hiccup there. I think like messed up one of the identity creation, but there's a pattern here. So let's just try to figure that out. So A will get identity, B will get identity, C will get identity, D will get identity here, E will get identity here. The only thing you're left with D and E. Basically, the pattern goes like, if you have one odd, one even, the output is just even inputs XOR together, which is we just saw. So let's just like try to do a similar thing together once again. I think there was a hiccup there. I think like messed up one of the identity creation, but there's a pattern here. So let's just try to figure that out. So A will get identity, B will get identity, C will get identity, D will get identity here, E will get identity here. The only thing you're left with D and E. Basically, the pattern goes like, if you have one odd, one even, the output is just even inputs XOR together, which is we just saw, D and E. Now the only thing left to discuss is the next pattern, which is if both of them are odd. So let's just do that as well. I think you can just like clearly observe if like both of them are odd. So the final output will be having AB. Basically all inputs XORed within each other, including the first array and the second array. So we can also discuss a more bigger example here as well. Let's just take that to just show the proof of concept. A, B, C, let's say is num1, D, E, F is num2. So the XOR will operation would look like A, D, A, E, A, F, B, D, B, E, B, F, C, D, C, E, C, F. Now, this all will get identity because they're getting repeated. Also, A will get identity, B will get identity, C will get identity. Now the only thing that are left here is A, B, C should have also, yeah, C, D, E, F. Basically what we just discussed. If both of them are odd, just XOR each of the inputs with each other, and you will have your output of the final XOR. So we just need to check if one of them condition is being satisfied, odd or even or odd, or vice, or whatever it goes like. And you can have the inputs and know what the output is going to be like. So let us see the code for this as well, which is finally when I got it right. Because I observed that must be a pattern here which would allow me to get the solution in a single iteration. Okay, so this is, I think, this is pretty straightforward. You would have observed that I'm now already taking the size of the two arrays into account. So I think already discussed that if both of them are even, then doesn't matter, the output is gonna be 0. If one of them is even and one of the other them is odd, then you have only the odd array, is it? Yeah, odd array. One, size 2 is odd, yeah. And the even array, I guess the output. Okay. So here the even array is getting the output here. And you would have observed here in this case, size 1, basically the first array is odd. So you get the even array, that is the array 2, contributing to the answer. Now here comes the final thing as well. If both of them are odd, so you just like XOR them with each other. So you have a global XOR, and you XOR the first array, you XOR the second array, and you keep XORing with the global